next example of integration with trig is using this function here, which is bounded. So we have the integral bounded from 0 to 1 of cos 4x dx. We're going to be using u substitution to make this simpler. We have u sub, where we have u is equal to 4x, du dx is 4, and then dx is du over 4. We can plug in u instead of 4x, so we get the integral of 0 to 1 cos u, and we replace dx with du over 4. Now I showed you how to do the properties of integration here, where I can just take this 4 out, because we're multiplying the whole thing by 4 technically. So we have 1 over 4, bounded 0 to 1 cos u du, and now we can simplify, or find the antiderivative. So we have f of x is equal to 1/4 sine. You see that I multiplied the quarter back in now that I don't have to deal with it anymore. 1/4 sine u bounded from 0 to 1. Remember to put these bounds here, that's still important. And also remember that the derivative of sine is cos, so when you're doing it backwards, cos becomes sine. So f of x is equal to 1/4 sine 4x bounded from 0 to 1 once you when you put the 4x in for your u. And now we need to do the fundamental theorem of calculus. F at 1 minus f at 0. This ends up being negative 0.189 minus 0. It's really difficult to find exact values using trig without going into your special triangles and your unit circles. So I just put it into the calculator and you use your value functions in order to find the exact number and round to 3 decimal places. And minus 0 does absolutely nothing. So now we know that the integral bounded from 0 to 1 of cos 4x dx is equal to negative 0.189. Next up, I'm going to be showing you how to find the integral of an unbounded rational. So we have the integral of x over the square root of x plus 1 dx, and we're going to be using u substitution to find out our answer. U is equal to x plus 1, du dx is equal to 1, and that just means that when we divide over, dx is just equal to du. And now we can show that the integral is u minus 1 divided by the square root of u. And you might be wondering where this u minus 1 came from, because there's not an x plus 1 in the top, there's just an x. Basically, we just rearranged for x, so we had x is equal to u minus 1 once you rearranged, so now you can just replace x with u minus 1. We also replace the dx with a du here, and then that's just the square root of u on the bottom. Now I separated it into its components, so it's easier to find out what our integral is. So we have the integral of u over the square root of u minus 1 over the square root of u du. In order to make things simpler for our antiderivative, we take this u over square root of u and we turn that into u to the 1/2. You may be wondering why it's not a negative, but when you take this to the top, you have u times u to the negative 1/2, and you add the exponents and you get 1/2. And this is just u to the negative 1/2, which is basic rationalization there. So if the integral of u to the 1/2 minus u to the negative 1/2 du. Now we can find the antiderivative, which is 2 over 3u, 3 over 2. And you may also be wondering why when we divided by the 3 over 2, this flipped. And I just want you to remember that 1 divided by 2 over 3 is the same thing as 3 over 2, because you can multiply it by its inverse. So we have this part here, minus 2u to the 1/2, and that's a much simpler one, plus c, because when you're doing integrals that are unbounded, you cannot forget to add the plus c. You never know when there's a constant there. This means that our final answer is the integral of 2 times x plus 1, which is the u that we substitute back in, to the power of 3 over 2 over 3, minus 2 times x plus 1 to the power of 1/2, plus c. In order to find our integral, which is our area between the curves, we need to follow this formula that we have in order to find area between curves, which is the integral of the top function, which is our linear, minus the bottom function, which is our parabola. Don't screw these two up or else you're going to have the wrong area. So we have the integral bounded from 0 to 2 of 2x minus x squared. Remember that I put the linear one first because it's on top of the other one. And now we can find the antiderivative by just adding 1 and moving to the bottom, and then doing the same thing with our x squared. You end up with 2x squared over 2 minus x to the 3 over 3. These 2's just cancel out and create a 1. You don't really need to worry about that, but I wrote them in so you wouldn't wonder where they went. And remember to put this notation that it's bounded from 0 to 2, but you've already found the antiderivative. Now you just need to do the fundamental theorem of calculus and plug in our b bound, which is 2, and the 0 for a. Subtract them, and you get 4 over 3, which is our area between curves. saw that video of Taylor and Emily playing Twister, and it just so happened that their legs lined up to kind of look like this graph right here. So this is when we're finding the area between curves again, but instead we have two parabolas. This is just showing a more complicated version of what we were doing before. So we have one upwards and one downwards, and they create this little space isolated from the rest, and this is the area we're trying to find. So our two functions are 1/3 x squared plus 2 and 1/2 x squared plus 5, or sorry, negative 1/2 x squared plus 5. First of all, we need to find our bounds, and our bounds are the 2 points where they intersect. So we make them equal to each other, and I moved the 1/3 x squared over to this side, and then I moved my positive 5 over to this side, which leaves us with negative 3 is equal to negative 5x squared over 6. I multiply by 6 and divide by negative 5, which leaves us with x squared is equal to 18 over 5. Then I took the square root of both sides. Remember, when you're doing the square root, you need to put the plus and minus sign unless it's out of your bounds. In this case, it is our bound, so it can't be out of it. So if x is equal to plus or minus the square root of 18 over 5. Now, it's kind of junky to write it on the integral, but just remember that you have to write them there every single time. So if the integral from negative square root of 18 over 5 to square root of 18 over 5 of our two functions subtracted by each other, it's always top minus bottom. And our top one is the black one here, which is negative 1/2 x squared plus 5. And the bottom is the pink 1/3 x squared plus 2. So I have them subtracting each other, and then we took the antiderivative, and the antiderivative of this one is negative 1 over 6x to the 3 plus 5x minus 1/3 x to the 3 plus 2x. This one is very simple, and you can just subtract them together, and we end up with f of x is equal to negative 5 over 18 plus 3x. And now we do the fundamental theorem of calculus in order to find out what our value is. We have f at the square root of 18 over 5, which is our b, and f at negative square root of 18 over 5, which is our a, and this ends up being f of x is equal to 11.384. Okay guys, you survived. You made it. You're finally done all of calculus. You better be ready for your final. And don't forget, we still have that project.
Our project? Oh yeah.
Hit it!
There's 90 or so days of Math 31 class, and summer comes along just to end it. So the semestral problem of our generation is finding a good way to solve it. Like maybe factoring questions or finding a limit, or struggling with optimization, discovering something that doesn't exist, or using up all our brain power. Finding the integrals area under the curve, or feeling just infinite pain is power law. Finding an answer, feeling incompetent, or driving each other insane. Ashlyn! As you can see, there's a whole lot of stuff to do before summer starts this June. Come on, Taylor.
I'm coming.
So stick with us, cause calculus students are gonna do it all. So stick with us, cause none of us know what's going on at all.
Shoemaker, Emily, and Taylor are ruining our math project.